Section 5.3 example 5b. Again, so we've seen this situation before. 1, 2, 3, 4 terms. This one's on the other side, so I have to bring it over, and then I'm going to factor by grouping. I've got cotangent squareds and cosecant squared, and so this is potentially one where I could try to substitute my cosecant squareds for my cotangent squareds and so on, but for right now what I'm going to do is factor by grouping. So I see these two have a cosecant squared, so I have, and I'm left with cotangent squared plus 2. These have a -1 in common, and I'm left with cotangent squared plus 2. Factoring by grouping worked. I did not have to substitute, okay? I could have, and I would have gotten the same solutions. So that's something that you need to be careful of and need to watch for. So I'm going to factor this out, and I'm left with cosecant squared minus 1. Use the zero product property. Now look what happens here. Cotangent squared of x equals a -2. I have a trig function squared equal to a negative. Here's the first time we've seen this. This one doesn't have any solutions, okay? And I guess this x equals empty set. This one over here, I do actually have solutions so the whole problem does not have no solution, just this one piece has no solution, okay? So I would add my 1 and then take the plus or minus square root of both sides. So this does not have no solution. So cosecant is equal to 1 at pi halves, and cosecant is equal to 1 at 3 pi halves. One at pi halves, I said, there we go. Cosecant is 1 at pi halves, and cosecant is -1 at 3 pi halves. I think I said it wrong the first time, but those are going to be your two solutions. So the problem itself does not have no solution, just this piece has no solution. The original problem has two solutions, pi halves and 3 pi halves.